Hi guys, this is Snow. In this video, we will implement a pathfinding algorithm so the characters can walk to a certain location while avoiding solid tiles. I will show you 3 examples. The one is setting a point on the map as a goal and let the old man moves to it. And the second example is making the old man follow the player character. And the third example is making these monsters aggro so they start chasing the player character. Programming algorithm is kind of an advanced technique, so this was not in my original roadmap, but pathfinding was one of the top requests that I've received, so I decided to add it. We use an algorithm called A-star search, and recently I uploaded a tutorial video about it and explained its fundamental mechanics in details. So if you have no knowledge of A-star pathfinding, I recommend you to check my A-star video first and learn its basics. So just so you know, I will not explain about the algorithm itself in this video. My explanation here will be focused on its implementation to this 2D game. Okay, so from here, I assume you already know how A-star algorithm works, so let's implement it into our game. First, create a package and name this like AI. Then create a class. Node class. So declare some class and variables. Node parent public int call public int allow int g cost int h cost int f cost and boolean solid boolean open boolean checked. The constructor public node get call and allow dot call equal call this dot allow equal allow. Oh no. Okay, so this class is done. Then create a class to handle the pathfinding. I'm gonna name this Pathfinder. Game panel and a node array list. Yeah, open list. Also another list, and this is public array list. Node path list node start node call node current node and the boolean goal reached equal false and also step. Okay, that's it. Then constructor public Pathfinder and we receive game panel. And then we're gonna instantiate this node. Instantiate nodes. Node equal new node. We're gonna use this max world call and max world allow. And also, yeah, let's call this method from this constructor. Then create while loop max world call and allow gp.max world allow node call allow call new node. We're gonna pass call and allow. Call plus plus. Call gb dot max. Call equal 0. Allow plus plus. Okay. So basically we create a node for every tile on the map. Okay, then create another method called reset nodes. In the actual game, we do this pathfinding again and again. So every time we do it, first we need to reset the previous result. Otherwise, the algorithm doesn't work. So we create another while loop and reset all the node data. So node call allow dot open equal false, checked equal false, solid equal false. And also after this loop, so we're gonna reset this open list, clear. So we're gonna clear this open list and also this path list, clear. And goal reached boolean is false and the step is 0. So we reset everything. Then we create a method called set nodes. As the parameters, we receive start call, start allow, goal call, goal allow, and entity. And first we call this set nodes method and reset everything. And this is where we set the current node settings. So we set the start, goal, and solid node, and also set G, H, and F cost on each node. So start node is node start call, start allow, then current node. So we set this start node as current node. All node is call allow. And after that, we only add the current node to this open list. Then create another while loop. And first we need to know which node should be solid. So we can get solid info from our tile class or other entity class. So int tile num equal gp.tile manager dot map tile num and gp.current map, and we're gonna pass this call and allow. Okay, then we call this tile array in this tile manager and put this tile number and check if collision status is true or not. And if it's solid, then we set this node's solid status to true. And we check the interactive tiles too. For example, if you have placed these dry trees, we need to set the corresponding nodes solid. So we scan the iTile array gp dot I tile 1 dot length and I plus plus. So make sure to add this dimension number, and then check if gp dot I tile dot gp dot current map and index I is destructible. So if it's true, then it is a solid object. So it call gp dot I tile gp dot current map index I dot world x divided by tile size, so we can get the column number. And also allow, just copy, and this time world y. And we're gonna use this colon allow to set this node solid true. Yeah, like this. And also we need to check not equal null, otherwise we can get null pointer error. So make sure to check if it's not equal null. Yep. Okay, then we set cost on this node. So we're gonna call this get cost method and pass node allow. And so now we're gonna create this get cost method. So public void get cost receive node, and first we get g cost. So we can get the g cost. Then h cost. Alright, let's copy. And this time not start node, but goal node. So h cost is, and finally f cost. So the most important one. So f cost is, okay, that's it. So the node settings are done. So now search the path. Public boolean and the search while goal reached goal false, and also we set some limit, so like step 500. And okay, int call current node dot call int allow call current node dot allow current node dot checked equal true open list dot remove current node, and then open the up node if allow -1 is greater or equal to 0. So we're gonna open this node, call allow -1. We're gonna create this method a bit later. So this time we're gonna use this max world allow max world call. Okay, let's create this open node method. And if node dot open equal false and node dot checked equal false, and node.solid equal false. Then we can open this node for evaluation, and also set current node as its parent, and also we're gonna add this to this open list so we can compare, and so we can scan the nodes in the open list and find the best one. And for loop int I, so open list dot size, so if open list dot get I dot f cost is smaller than best node f cost, then we're gonna update this best node index and also best node f cost. And if f cost is equal, check the g cost. Then if open list dot get I dot g cost is smaller than open list dot get best node index g cost. So this time also we're gonna update this best node index. If there is no node in the open list, then we end this loop. So if open list dot size is 0, then we're gonna end this loop. Okay. So current node equal open list dot get best node index, and if current node is goal node, then goal reached equal true. Then we're gonna call track the path method that we're gonna create after this, and also in every this while loop we're gonna increase this step. Okay. And also finally, so since this is a boolean, so we're gonna return boolean, return goal reached. And okay, so let's create this method. Node current goal node, while current is not equal start node, so we're gonna backtrack from the goal node to the start node. So this time we're gonna put these nodes to this path list. So at 0 current, one by one, current equal current dot parent. So we're gonna update the current node. So this path list is pretty important. With this list, NPCs or monsters can track the path. Okay, so this Pathfinder class is also done. So now open this entity class and at the boolean, public boolean on path or something like that. And we're gonna use this old man NPC class. So for example, let's change it. So when you talk to this old man, he starts moving to a specific location. When you play games, this kind of thing often happens. Like when you talk to an NPC, he says, just follow me or something like that. And so he starts walking to the next town or nearby cave or something like that. So when we talk to him, we're gonna set his on path to true. And then inside of this set action, is we're gonna add an if statement. If on path equal true. And so we're gonna put the rest in this else like this. And what we do here is set its goal as call and allow. And pass these to a method called search pass. So that we will create after this. Let's assume this is the old man's home, and when we talk to him, he starts walking to this location. Okay, let's get so call 12 and allow 9. So we're gonna set the number. Goal call is 12, allow is 9. Then go back to the entity class and create this search path method. So public void search path, receive goal call and goal allow. But before working on this method, we create another method and called public void check collision, and we're gonna move these collision checking stuff in the update method to this new method, and we just call this method from here. So because we'll need to check collision as we track the path, and I thought having these collision checking stuff in a separated method is more convenient, so we don't need to type the same thing again. Okay, first let's instantiate class in this game panel, public Pathfinder, Pathfinder or something, new Pathfinder. This. Okay, now let's work on this search path method. So here we get start call and allow. So start call and start allow. And this is where this entity is. So world x plus solitary x divided by tile size, so we can get the call number of this entity. Okay, so now we know start call, start allow, and goal call, goal allow. So next we're gonna call this set nodes method. gp.pfinder set nodes and the path start call, start allow, goal call, goal allow, and this is entity, so we're gonna pass this. So we have passed necessary data to run the path search. So we call this search method and check if it return true. So if gp.pfinder.search, and so if it return true, that means it has found a path, so we can guide this entity to the goal. And path data is in this path list, and we check what node is in its slot number 0 and which is next to the start node, and that's where this entity should go next. And we get its world x and world y. Next world x and the world y. So I'm gonna name this simply next x equal gp.pfinder. So we're gonna call this path list and get index 0, call times tile size. So we're gonna get its world x, and the next y is gp.pfinder.pathList.get index 0's loud times tile size. Then we also get this entity's current solid areas positions. Okay, I'm gonna name this n left x, entities left x equal world x plus solid area dot x, entities right x equal world x plus solid area dot x plus solid area dot width, and entities top y equal world y plus solid area dot y, and entities bottom y equal world y plus solid area dot y plus solid area dot height. Yep. Then we're gonna use these numbers and compare these world x and world y, and these entities world x and world y, and decide a direction of this entity. We're gonna create a lot of if statements here to make sure this entity won't get stuck. So this was pretty tricky, and it took me a while to make it work. And I don't think this is the only way, but among many methods that I tried, this worked good for me, so I'm going to show you how I did it. So we're going to check entities top y is greater than next y, and entities left x is greater or equal to next x, and entities right x is smaller than next x plus gp.tile size. So if these conditions are matched, this entity can go up. Okay. Copy and paste, and else if. So we're gonna check the opposite. So top y is smaller than next y, and these are the same. So in this case, this entity can go down. And else if entities top y is greater or equal to next y, and entities bottom y is smaller than next y plus tile size, and not toy top. In that case, this entity can go either left or right. So we're gonna check that. So if entities left x is greater than next x, then direction should be left. And if entities left x is smaller than next x, then direction should be right. So with this, we can cover most of the case, but still there are some situations that none of these conditions are matched. So we need to take care of other exceptions. Okay, so else if entities top y is greater than next to y, and entities left x is greater than next to x. Why I always type toy top y? So in this case, direction is either up or left, because this entity's y position is below the next tile, and also this entity is on the right side of the next tile. So yeah, so the direction should be up or left. So we set direction to up for now, but we are not so sure. Maybe there is a collision tile above him. So we're gonna call that check collision method. And if collision is true, then direction is left. And the next one is else if entity top y is greater than next y, and this time entity left x is smaller than next x, then in this case direction should be up or right. So first set direction to up, and okay, check collision, and if collision is true, then direction is right. And two more, else if this time entity top y is smaller than next y, and entity left x is greater than next x. In this case, direction should be down or left. So first set direction to down, then check collision, and if collision is true, direction is left. And copy and paste, and this time this entity left x is smaller than next x, then direction is down or right. So change this to right. Okay, yeah, that's everything. Okay, also if you want to stop the entity when it reaches the goal, then so we need next call and next log. Maybe we could have created this earlier. Log. So if next call equal call call, and next log equal call log, then we're gonna set this on path to false. So as long as this old man is on path, it keeps calling this search path method and getting the next tile information until it reaches the goal. So I think it works now, so let's check. Alright, talk to old man, and then now he starts walking. So he's going back to his home, slowly though. Yep. So he's safely back in his home. So the NPC found the path and moved to the goal location. And we can also display his path on the screen in this tile manager class, like a boolean draw path and equal true. And here in this draw method, so if draw path equal true, so basically we're gonna draw some rectangles, and I'm gonna choose red, half transparent red, and for loop we're gonna scan that path list, and we need to get its screen X and the screen Y. So okay, let's copy this and paste, and world X is the gp.p finder.path list.get index I dot call times time size. So we get the world X, and okay, world Y is law times tile size. Then we're gonna fill rect and the screen X, screen Y, and tile size. Alright, let's check. And okay, let me change old man's walking speed a little bit. So yeah, like this. So now we can see his path. So he's tracking the path like this. Okay, it's working good. So next, let's make him follow the player. And it's actually pretty simple. So we just change this goal call and goal allow to player's position. So change this to player.world X plus player.solid player.x, not default X. And so we're gonna divide it by tile size, so we're gonna get the call number. And okay, so allow is world Y. Okay. Also, yeah, we need to disable this, because if the player is the goal, the old man instantly reaches the goal when we talk to him, and the old man just stops following us. So disable this. Okay, and let's check. Alright, let's talk to him. Alright, so now he starts following us. Yep. So he automatically finds the shortest path to the player. Yep. Okay, I think. So now the final part. So monsters getting aggro and start attacking you or chasing you. So let's open this slime class. And this set action method is basically the same as the old man, so I think we can just copy and paste. Copy, paste. Okay, so the goal is player. And okay, and so yeah, this projectile, so let's change. This slime shoots rocks only when they are aggro. Like when it starts shooting rocks, then we know they are angry or they are aggro. So we can move in this on pass, and probably we can increase the percentage more than 197 or something. And now we decide conditions that this monster gets aggro, and you can choose any conditions that you want. And so here's an example. I'm gonna set two conditions. The one is when player attacks this slime, then it gets aggro 100%. And the other one is when player gets close to it, when he gets in a certain distance. So first one we can take care inside of this damage reaction. So instead of moving away from this player, when it receives damage, we set on pass to true. So it instantly becomes aggro. So right now they are passive, but if you attack it, then suddenly it becomes aggro and starts chasing player. Alright, then let's take care of the other condition. So let's say if player gets close to this slime, like within 5 tiles, then it can get aggro. And to handle that, we override the update method. Public void update. And first we're gonna call update in its superclass because we still need to handle the normal update stuff. But after this, we check the distance between player and this slime. So we get the total distance as tile size, so tile distance equal x distance plus y distance divided by tile size. And if so, on pass is false and tile distance is less than 5, then we can just set this on pass true here, but I think I wanna randomize it a little bit, so I'm gonna use random class. And if I is greater than 50 or something, so 50% of the time it becomes aggro, because I thought it would be a bit robotic if slime always gets aggro 100%, so I wanted to randomize it a little bit. And if you like, you can also set a condition that the slime abandon the chase. Like if you take 20 tiles distance, then the slime gives up chasing you or something like that. Like on pass, if it's already on pass, but the tile distance is greater than 20 or something, then on pass is false or something. I'm not gonna use this in this demo, but yeah, this is also another example. Okay, I think that's everything. Alright, let's check. Hope this works. So if you get in within 5 tile distance, then I think that slime is aggro now. So yeah, so it starts shooting the rock. Okay, let's put more slimes. And yeah, what? Okay, let's talk to old man too. You follow me. Oh. This looks pretty crazy. All the slimes are chasing us. What are we gonna do, old man? Oh, they are coming. Now they are here. Oops, I died. No, I feel like I need a shield. Oof. Yep, so now the slime gets aggro when player gets too close to it, so the battle suddenly becomes more challenging. We've implemented A-star pathfinding algorithm, so now NPCs and monsters have an ability to find a path and get to the assigned goal. So this definitely helps to create more complicated game mechanics. So please utilize it however you want and make your game more interesting. Thanks for watching, and until next time.